Welcome to this FP2 video on trigonometric identities. Now this is when we're involving de Moivre's theorem. So we can use de Moivre's theorem to derive different trigonometric identities by basically applying, the cos theta I sine theta to the power n being equivalent to then cos n theta plus I sine n theta. And if we want, like say cos 4 theta, cos 5 theta, cos 6 theta, then we're looking at just the real part of this expansion. And if we want like sine 6 theta, sine 5 theta, whatever, we want the imaginary part of this expansion. So this is going to be used in conjunction with, if you remember back to P2 where we did binomial expansion. So this would have been a to the power n plus nc1 a to the power n minus 1b plus nc2 a to the power n minus 2b squared, and so on all the way up to NCR a to the power n minus r b to the power r, and then up to just b to the power n. Okay, and you all know what NCR is now. That's n factorial over r factorial brackets n minus 1 factorial. Or you can simply put it into your calculator. So we're going to use these now to solve more problems, but trig problems involving de Moivre's theorem. So let's jump into the first example. So we want cos 6 theta. So we want to do cos plus I sine theta to the power 6. Because that's then going to give us our 6 cos theta and plus I sine 6 theta. But we want this cos 6 theta. So now what we want to do is expand. So cos theta plus I sine theta to the power 6. Now this is going to expand to cos theta to the power 6 plus 6c1 cos to the power 5 theta I sine theta plus 6c2 cos to the 4 theta I sine theta squared, plus and so on. Okay, so here it is. Now I need to deal with like my i's, because an I squared is going to be a minus 1. So I've got cos 6 theta plus, now 6c1 is 6 I cos 5 theta sine theta. Now 6c2 is 15, and in this one I squared is going to be minus 1. So this is going to be minus 15 cos 4 theta sine squared theta plus 6c3 is going to be 20, and we've got I cubed, which is going to be minus I. So this will be not plus, it'll be minus. So minus 20i cos cubed theta sine cubed theta. Now 6c4 is 15 cos squared. Now I to the power 4 is I squared times I squared, or minus 1 times minus 1, which will be plus. So 15 well, we got cos squared sine to the power 4. Just squeezing that in there. Plus 6c5 is 6 cos theta. I to the power 5 is going to be I squared times I squared, which is 1 times I. So 6I cos theta sine to the power 5 theta. Plus, and then this is I to the power 6, so I squared then cubed. So it's actually going to be minus sine theta to the power 6. So that is my expansion of this. Now what we want to look at is that this is obviously the same as this, isn't it? So this was obviously equal to this. And we want this cos 6 theta, so we want to equate real parts. So that means that cos 6 theta equals, now cos to the power 6 theta, we don't want this one because it's got an I in it, we want this one, minus 15 cos to the 4 theta sine squared theta. We don't want this one because it's got an I in it, so we want this one, plus 15 cos squared theta sine to the 4 theta. We don't want our next one, and we want the final one, sine to the power 6 theta. Now this obviously right now isn't in this form, but what we can do is get rid of the signs, because in here it contains only cos, and we know that sine squared plus cos squared theta equals 1, and sine squared theta is going to be equal to 1 minus cos squared theta. So this is cos to the 6 theta minus 15 cos 4 theta 1 minus cos squared theta plus 15 cos squared theta, and then this is going to be 1 minus cos squared theta squared, minus 1 minus cos squared theta cubed. So taking out a cos squared theta and raising it to the power 3, taking out a sine squared theta, and raising it to the power 2. Now I can expand all of these. So I get 15 cos to the 4 theta plus 15 cos to the 6 theta. Now this is 1 minus 2 cos squared theta plus cos to the 4 theta minus, I'm not going to be able to fit it in on that line, so 1 minus 3 cos squared theta plus 3 cos to the 4 theta minus cos to the 6 theta. So we've got 15, so 16 cos to the 6 theta at the moment, minus 15 cos to the 4 theta. That's just dealing with these three, but now I've got to expand this one. So plus 15 cos squared theta minus 30 cos to the 4 theta plus 15 cos to the 6 theta minus 1 plus 3 cos squared theta minus 3 cos to the 4 theta plus cos to the 6 theta. Now simplifying this, so we've got 16 to the power 6 plus 15 and 16, so that is 32 cos to the 6 theta. We've got minus 15, these are the cos to the power 4s now, so minus 15, minus 30, that's minus 45, minus 3, so it's minus 48 cos to the 4 theta. Now we're looking at the squared ones, so it's 15 plus 3 is 18. And then we've got just this minus 1. And that is as we required. Okay, so that's how we do it, and we can do a similar thing with the same start for sine 6 theta, you know, so the same initial expansion, and then we'd equate the imaginary parts. Okay, and then we'd have sine 6 theta. Now this is actually part of an exam question, previous exam question, and let's look at then how you did it. This was like the part A. Let's look at the part B of that question. So this is the part B of that question, hence find the 6 distinct solutions to this equation. Now we've got this. So if, you know, I said let x equal cos theta, then 32x to the power 6 minus 48x to the power 4 plus 18x squared minus 3 over 2 would be equal to 32 cos to the power 6 theta minus 48 cos to the power 4 theta plus 18 cos squared theta minus 3 over 2. Okay, and this is almost this, isn't it? That are correct, but we've got minus 1 there. So if I change this minus 3 over 2 to minus 1 minus a half, and this would be, of course, equal to 0, because this equals 0. Now this is cos to the cos 6 theta, isn't it? Minus a half equals 0, or cos 6 theta equals a half. Now that means that 6 theta is plus or minus pi by 3 plus 2k pi. Okay, this is the general term for the angle, because if you do, you know, a half inverse cos, you get the third pi. And if you think of the cast rule, you've got pi by 3 here, and then this angle is minus pi by 3. And then basically every 2 pi you get multiples of this angle, and every 2 pi you get multiples of this angle. So plus or minus pi by 3 plus 2k pi, where k is integers. So that gives me the general solution. Now I've got 6 theta, so if I want to find what theta is, I'm dividing by 6. So plus or minus pi over 18 plus k pi by 3. So first plug in k equals 0, we get theta equals pi by 18, or theta equals minus pi by 18. Okay, plug in k equals 1, we get theta equals pi by 18 plus pi by 3, which is 7 pi by 18, or theta equals minus pi by 18 plus pi by 3, so it's 5 pi by 18, and then k equals 2, we get theta equals pi by 18 plus 2 pi by 3, which is 13 pi by 18, or theta equals minus pi by 18 plus 2 pi by 3, and that gives me 11 pi by 18. Now, I'm not keen with this -1, so I'm just going to do one more. K equals 3, and this is going to give me 19 pi by 18, or 17 pi by 18. And I'm going to take now all the positive ones that go up to pi, basically, so 0 to pi. So I've got 1, 2, 3, 4, 5, 6. Or theta equals pi by 18, 5 pi by 18, 7 pi by 18, 11 pi by 18, 13 pi by 18, and 17 pi by 18. The reason I got rid of the minus pi by 18 was just because it could have been equivalent to one of these values. So it's just easier to take all the positive ones between 0 and pi. So here they are now, the 6 distinct values. I'd have 6 positive ones and 6 negative ones. If we're looking between, minus pi and pi, but we're looking for the 6. But some of the negative ones will give me the same answer as the positive ones. Okay. So now we need to use our x equals cos theta. So x equals cos theta. Therefore, x is going to be cos of pi by 18, which gives me 0.985 to 3 decimal places. Or cos of 5 pi by 18 is 0.643 to 3 decimal places. Or cos of 7 pi by 18 is 0.342 to 3 decimal places. Now going into the 11 pi by 18, so cos of 11 pi by 18 is minus 0.342, so this one becomes plus or minus. Now when I do cos of 13 pi by 18, I get minus 0.643, so this one becomes plus or minus. And again, when I do the 17 pi by 18, this one becomes plus or minus. So those now are my 6 distinct solutions to this equation. Okay, and that there is how we do that type of question. So hopefully you managed to follow it. Okay, any questions, let me know in the comments. Now, before we actually get into practicing some questions, we've done how to expand and get, cos 6 theta in terms of powers. But now I want to do, something in powers in terms of multiples of angles. So like cos to the 6 theta equals, and then in terms of multiples of angles. But before we do that, we need a little bit more help. And the help is going to come in the form of 4 results. Okay, so let's have a look at those. So first I'll go through it, but we only really need the results, but I will show you. So if we look at z being our complex number here, z is cos theta plus I sine theta. That means that 1 over z, or z to the minus 1, would be cos theta plus I sine theta to the power minus 1. And then using De Moivre's theorem, that would mean it's cos to the minus theta plus I sine to the minus theta. And we all know that this is just simply cos theta minus I sine theta. So that gives me my 1 over z. So what does that mean? Well, that means that if I do z plus 1 over z, I get cos theta plus I sine theta plus cos theta minus I sine theta for adding this and this. This means that both the I sine thetas will cancel, leaving me with 2 cos theta. And equally, if I did z minus 1 over z, I get cos theta plus I sine theta minus cos theta minus I sine theta. The cos thetas here will cancel, and this one will become a positive, so I got 2I sine theta. And this is going to form the basis of what's going to become very useful in answering these questions, really. Now, if we think of the same thing, but this time z to the power n, this is cos theta plus I sine theta to the power n, or cos n theta plus I sine n theta. And if I think of 1 over z to the power n, that's z to the negative n, which is cos theta plus I sine theta to the power minus n, which is cos to the minus n theta plus I sine to the minus n theta, which we know is cos n theta minus I sine n theta. Okay, so in the same process as here, we've just got now z to the power n and 1 over z to the power n. Now if we did as we did before and add them, z to the power n plus 1 over z to the power n, that gives me cos n theta plus I sine n theta plus cos n theta minus sine n theta, which is of course cancelling out the sines, 2 cos n theta. And similarly, z to the n minus 1 over z to the n, I'm not going to write it out in full. This is going to be 2I sine n theta, just doing the same as before. So what I've ended up with is basically a couple of sets of results. So z plus 1 over z is going to be 2 cos theta. Z minus 1 over z is 2I sine theta. And z to the n plus 1 over z to the n is 2 cos n theta. And z to the n minus 1 over z to the n is 2I sine n theta. And these results are all we need to worry about. We need to remember these 4 results. Now let's look at how we would use them. So here I've got cos to the power 7, cos theta to the power 7, and I'm going to express that in the form of a cos to the 7 theta plus b cos to the 5 theta plus c cos to the 3 theta plus d cos theta. So first of all, let's let z equal cos theta plus I sine theta. So that's what I'm going to start off with. Now, we want to get in terms of causes. So that's going to be z plus 1 over z, because that's going to give me like a 2 cos theta. So z plus 1 over z, and we're going to do this to the power 7. So that's going to be 2 cos theta to the power 7, which is going to be 2 to the power 7 is 128 cos to the 7 theta. Okay, now also the expansion of that is going to be z to the power 7 plus 7c1 z to the power 6 1 over z plus 7c2 z to the 5. I'm using binomial expansion here. 1 over z squared. I'll actually just put 1 over z squared. It's the whole thing squared, but you get the same thing there. 7c3 z to the power 4 1 over z cubed plus 7 c4 z to the power 3 1 over z4 plus 7 c5 z squared 1 over z to the 5 plus 7 c6 z and 1 over z to the 6 plus 1 over z to the 7. So what I've got here is 7c1 is 7. So we've got z to the power 7 plus 7. And z to the power 6 multiplied by 1 over z is z to the power 5. Now 7c2 is 21. And z to the power 5 multiplied by 1 over z squared is z to the power 3. Now 7c3 is 35. And z to the power 4 multiplied by 1 over z cubed is just z. Plus, now 7c4 is also 35. Now, z cubed multiplied by 1 over z to the 4 is 1 over z plus, and then we've got 21 1 over z cubed plus 7 1 over z to the power 5 plus 1 over z to the power 7. Now I can put these together. So z to the power 7 plus 1 over z to the 7 plus 7 z to the 5 plus 1 over z to the 5 plus 21 z cubed plus 1 over z cubed plus 35 z plus 1 over z. So I'm collating the 7s, the 1s to the 7, to the power 5s, to the power 3s, and to the power 1s. Now, using the results that we just established, z to the power 7 plus 1 over z to the 7 is going to be 2 cos 7 theta plus now 7 brackets, and z to the power 5 plus 1 over z to the power 5 is 2 cos 5 theta. And then we've got 21 times 2 cos 3 theta plus 35 times cos 2 to the cos theta. So we've got 2 cos 7 theta plus 14 cos 5 theta plus 42 cos 3 theta plus 70 cos theta. And this, of course, is equal to this, 128 cos 7 theta. Now we want just cos to the power 7 theta, so we need to now divide by 128. So we've got 1 over 64 cos 7 theta plus 7 over 64 cos 5 theta plus 21 over 64 cos 3 theta plus 35 over 64 cos theta. So there we have my A is 1 over 64, my B is 7 over 64, my C is 21 over 64, and my D is 35 over 64. So just remembering at the end, because we just want cos to the power 7 theta, we've also got to divide by this number here, this 128 in this case. Now, before we get onto the questions, like I have said before, I want to do one more example. So let's have a look at it. So this example is in 2 parts. Part A is just like what we just did, and part B then is using that. So let's start with part A. It's just the same as before. So let z equal cos theta plus I sine theta. Then we want to find sine, so we want z minus z in this case to the power 4. And that's going to be 2I sine theta to the power 4, which will be 16I sine to the power 4 theta. Now, expanding the z minus 1 over z to the power 4, it's going to be z to the power 4 plus, now 4c1 is 4, I'm just going to put that in there this time, z cubed minus 1 over z plus 6z squared minus 1 over z squared plus 4z minus 1 over z cubed plus 1 over z to the power 4, and that's obviously a minus. So this gives me z to the power 4, not plus, minus 4z squared plus 6. Now we've got 4, this is going to be minus, isn't it? So minus 4, and it's going to be 1 over z squared. And then this is going to be plus, then minus, so plus, sorry, minus, then plus 1 over z to the 4. So putting them together, we get this. Now taking minus 4 outside, we get z squared plus 1 over z squared plus 6. So we get 2 cos 4 theta minus 8 cos 2 theta plus 6. Now all that's left is to divide by my 16. And I apologise, I've just spotted a mistake. This I is to the power 4. So that is just 16 sine to the power 4 theta. Okay, so apologise, I was to the power 4. So this is 16 sine to the 4 theta, which means that sine theta is 1 over 8 cos 4 theta minus 1 over 2 cos 2 theta plus 3 over 8. Okay, now let's move on to part B. So we're integrating between pi by 2 and 0 of sine to the power 4 theta d theta. So this is between pi by 2 and 0 of cos 4 theta 1 over 8 minus 1 over 2 cos 2 theta plus 3 over 8 d theta. Now, cos integrates to sine 4 theta, divide by my 4, so 1 over 32. Cos integrates to sine, so this is going to be sine 2 theta divided by 2 plus 3/8 theta. And this is between pi by 2 and 0. So we got 1 over 32 sine of 2 pi minus 1 over 4 sine of pi plus 3 over 8 times pi by 2 minus, and then sine of 0 is 0, so this is going to be 0 minus 0 plus 0. Okay, so sine of 2 pi is 0, sine of pi is 0 plus 3 pi by 16. So my final answer is 3 pi by 16. And that's where converting from a power into multiples of an angle can be very useful, like in terms of integrating. Okay, it's one option for you. Right, let's look at some questions. So 4 questions for you to have a go at. Pause the video now. Welcome back. Right, let's have a look at the solutions to these questions. They were all past exam questions, so let's have a go. So we want cos to the 5 theta, so let's start off with cos theta plus I sine theta to the power 5. Because this is going to be cos to the 5 theta plus I sine to the 5 theta. Now expanding my cos theta plus I sine theta all to the power 5, we get cos to the power 5 theta plus 5 cos to the power 4 theta I sine theta. I'll put the I with the 5. Plus 10 cos to the power 3 theta I squared, that's going to turn this into a minus, sine squared theta. So it's still going to be a squared minus here because we've got 10 cos squared theta sine cube theta. So that is minus I, which gives me the minus 10. Plus 5 cos theta sine theta to the power 4. So I to the power 4 is going to be plus 1. And then finally, we've got I sine to the power 5 theta. So equating real parts gives me cos to the 5 theta is cos to the power 5 theta minus 10 cos cubed sine squared theta plus 5 cos theta sine to the power 4 theta. So just taking the ones without an I in for my real parts, okay, because obviously the ones with the I are the imaginary parts. Now I want this totally in terms of cos, so you know the drill here. It's turning the sine squareds into 1 minus cos squared. And there we have part A done. Now let's move on to part B. So part B says, hence given that also cos 3 theta is that, find all the solutions of cos 5 theta plus 5 cos 3 theta. So cos 5 theta plus 5 cos 3 theta equals 0. So cos 5 theta is 16 cos 5 theta, the power 5 I should say, minus 20 cos cubed theta plus 5 cos theta plus, now this is 5 times 4 cos cubed theta minus 3 cos theta, and this equals to 0. So we got 16 cos to the 5 theta minus 20 cos cubed theta plus 5 cos theta plus 20 cos cubed theta minus 15 cos theta. So the 20 cos cubes will cancel. So we're left with 16 cos to the 5 theta minus 10 cos theta equals 0. So factorising out 2 cos theta gives me 8 cos to the 4 theta minus 5 equals 0. So either 2 cos theta equals 0 or 8 cos to the power 4 theta minus 5 equals 0. So this would be cos to the 4 theta, cos to the power 4 theta equals 5 over 8. Cos theta equals plus or minus the 4th root of 5 over 8. So this one, theta equals pi by 2. Then my second one is 0.475 and 2.666. And those are the solutions between 0 and pi there. Okay, so that's question 1 complete. Let's have a look at number 2. Right, let's have a look at part A. So we got 32 cos to the power 6 theta. So let z equal cos theta plus I sine theta. Then z plus 1 over z to the power 6 is going to be 2 cos theta to the power 6, which is 2 to the power 6, which is 64 cos to the 6 theta. Now, expanding z plus 1 over z to the power 6, we get z to the power 6. In fact, I'll forward this quite quickly. And this, of course, is 64 cos to the power 6 theta. We want 32 cos to the power 6 theta. So dividing by 2. Oh, I missed out the plus 20 there, plus 10. And there we have it as required. Now part B, we want between pi by 6 and 0 cos to the power 6 theta d theta. So that is between pi by 6 and 0. This is going to be 1 over 32 cos 6 theta plus 6 over 32, which is 3/16 cos 4 theta plus 15 over 32 cos 2 theta plus 10 over 32, which is 5/16 d theta. I'll just make a little bit of room. Now integrating, cos integrates to sine, and we have 1 over 192 sine 6 theta plus 3 over 64 sine 4 theta 15 over 64 sine 2 theta plus 5 over 16 theta. And this is between pi by 6 and 0. Obviously, when I'm putting in 0, all of these are going to return 0. So I'm just going to do the pi by 6. We got 1 over 192 sine of 6 times pi by 6 is pi plus 3 over 64 times. Now 4 times by pi by 6 is going to be sine 2 pi by 3 plus 15 over 64 sine pi by 3 plus 5 over 16 times pi by 6, and all that is taken away 0. So sine of pi is 0, so we've got 0 plus, we've got 3 root 3 over 128 plus 15 root 3 over 128 plus 5 pi over 96. So we've got 18 root 3 over 128 plus 5 pi over 96. This will be 9 over 64. So 9 root 3 over 64 plus 5 pi over 96. And A and B are rational constants, and that fits this form, where B is the 9 over 64 and A is the 5 over 96. So that's question 2 complete. So for this one, there is kind of the standard way of doing it. So work out cos 6 theta, work out cos 4 theta and cos 2 theta, and put that together on the right hand side and then simplify it, and you should end up with this. But I do feel like there is a quicker way of doing it, and I'm going to show you it now. Whether you find it easier or not, you can still do it the way that I showed you how to find cos 6 theta in terms of powers earlier, and cos 4 theta the same and cos 2 theta the same. Okay, because really, you don't have to, you can equate obviously the real part, but you don't have to get it all in terms of cos, because this is cos and sine. Okay, so it should cancel. I'll explain it quickly. So this method, so cos 6 theta, so if you expand this, so you're expanding cos theta plus I sine theta to the power 6 equals cos 6 theta plus I sine 6 theta. And you'd get cos to the power 6 theta, you'd get plus 6I cos 5 theta sine theta. Then you'd have minus 15 cos to the 4 theta sine squared theta. Then minus 20I cos cubed theta sine cubed theta. Then 15 cos squared theta sine to the power 4 theta. Then 6I cos theta sine to the power 5 theta. And then finally sine to the power 6 theta. And equating, just obviously you want the real parts. So that would mean that the ones with the i's would go. So basically your cos 6 theta is cos to the power 6 theta minus 15 cos to the 4 theta sine squared theta plus 15 cos squared theta sine to the 4 theta minus sine to the power 6 theta. And then you do the same for cos 4 theta and cos 2 theta. But like I said, I think there's a quicker way of doing it. So let's get rid of this and let me show you. So first, z plus 1 over z, which I'll write as z to the minus 1. This is equal to 2 cos theta. Okay, now if I divide by 2, get rid of the 2 there, and this becomes half in front. Now that I've got this, and let's do the same with z minus 1 over z. I won't put the half in yet. So it's 2I sine theta. So divide by the 2I, we get 1 over 2I here. And there we have our z's in terms of cos theta and a sine theta. Now I want to create what I've got up here. So this is cos squared. So this is squared. And this is sine to the power 4. So this is to the power 4. So what I've got here is 32 a half z plus z minus 1 squared and 1 over 2I z minus 1 to the power 4. So let's sort out these. So a half to the power 2 is a quarter, and 1 over 2I to the power 4 is 1/16, and it's positive. So I've got a quarter times a 16th, that's 1 over 64. So I've got 32 over 64, z plus z to the minus 1 squared, z minus z to the minus 1 to the power 4. Okay, so now I can go ahead and expand these brackets. So I'm just going to give myself plenty of room. So 32 over 64 is a half. Now z, so this is going to be z squared plus 2 z times z to the minus 1 is just 1 plus z to the minus 2. And then expanding the 1 to the power 4, I've got z to the power 4 plus 4. Now this is z cubed times minus z to the minus 1. So that is going to be z squared, and it's a negative. Plus, now we've got 6, and that's going to be z squared times a negative z to the minus 2, so that's just going to be 6 plus 4. Now z times a negative z to the minus 3 is going to be z to the minus 2 and negative, yeah, because it's 4 times z times minus 1 over z cubed. Okay, that's what I'm doing there. And then finally we've got minus z to the minus 1 to the power 4. This is plus z to the minus 4. Now I just multiply the two brackets. So first I'm going to do z squared times everything in this right hand bracket. So that's going to become z to the 6 minus 4z to the 4 plus 6z squared minus 4 plus z to the minus 2. Now I'm going to do 2 times everything over there. So that's going to be plus 2z to the 4 minus 8z squared plus 12 minus 8z to the minus 2 plus 2z to the minus 4. And then I'm going to do z to the minus 2 times everything in the right hand bracket. So that is going to be plus z squared minus 4 plus 6z to the minus 2 minus 4z to the minus 4 plus z to the minus 6. Now let me simplify. So I've got z to the 6. Now in terms of z to the power 4, I've got the minus 4 here. I've got 2 here. And that's it, isn't it? So I've got minus 2z to the power 4. Then if we look at the squares, I've got 6z squared there. I've got minus 8z squared there. So that is minus, sorry, there's another z squared there. So I've got 7z squared minus 8z squared, so it's minus z squared. And then in terms of numbers, I've got minus 4 plus 12 minus 4. So that is 12 minus 8, which is 4. Now, when I go through working out my negative powers, it's very much the same as the positive powers. So I'll do it quickly, but you can look at them there. So it's 2z to the minus 4 minus z to the minus 2. Okay, now if I put these now together, so z to the 6 plus z to the minus 6 minus 2z to the 4 plus z to the minus 4 minus z squared plus z to the minus 2 plus 4. Just making a bit more room there. So we've got a half. Now this is 2 cos 6 theta minus 4 cos 4 theta minus 2 cos 2 theta plus 4. And times by a half, we get cos 6 theta minus 2 cos 4 theta minus cos 2 theta plus, not 4, I was going to write then, plus 2 as required. So there you have it, same as up here. I think you hopefully will agree with me that it was a little bit easier, maybe a little bit quicker doing it in terms of z instead of doing cos 6 theta, cos 4 theta and cos 2 theta expansions and collating together. But let me know in the comments if you agree with me that this way was maybe slightly better. Okay, and let me know if you did it this way yourself. Right, let's look at part B. So part B, we are integrating between pi by 3 and 0. We're integrating cos squared sine to the power 4 thetas d theta. So that will be 1 over 32, because we need to divide by the 32 here, so that then we can use this substitution. So cos 6 theta minus 2 cos 4 theta minus cos 2 theta plus 2 d theta, and that's between pi by 3 and 0. So 1 over 32. Now cos integrates to sine. So sine 6 theta over 6 minus sine 4 theta. Now it would be divided by 4, but obviously it was times by 2, so that's going to be divided by 2 minus sine 2 theta over 2 plus 2 theta. And between pi by 3 and 0. So as we said before, substituting in 0 is going to give me 0. So I won't need to worry about that one. So let's substitute in. So 6 theta, theta is pi by 3. that's going to be 2 pi over 6 minus, now pi by 3 is going to be sine 4 pi by 3 over 2 minus sine 2 pi by 3 over 2 plus 2 times pi by 3, and then minus the 0 at the end. So 1 over 32. Now sine of 2 pi is 0. Now sine of 4 pi by 3 is negative root 3 over 2. Divide by 2. So this, and it's already a negative, so it's going to become a positive root 3 over 4. And then we're going to have a negative root 3 over 4 plus 2 pi by 3. So these two are going to cancel with each other. So it's going to be 1/16 times by the pi by 3 really, isn't it? So it's going to be pi by 48 once I've simplified. And let's move on to the final question. So part A is use Tomorrow's theorem to show that sine 4 theta equals that. So let's start off with the fact that cos theta plus I sine theta to the power 4 is going to be cos 4 theta plus I sine 4 theta. And then I'm going to expand this. So it's going to be cos to the 4 theta plus 4 cos cubed theta I sine theta, so that's 4i, plus 6 cos squared theta I squared sine theta, so the I squared is going to turn this into a minus 1, plus 4 cos theta, now it's sine cubed theta, so that's going to be a negative I, so it's going to be minus 4i. And then finally we've got sine to the I sine to the power 4. I to the power 4 is positive, so it's sine to the power 4 theta. Now we want to equate imaginary. Okay, so that means that I sine 4 theta is 4, if I take the i's outside, 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta. Therefore, sine to the 4 theta is 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta as required up here. Okay, so we've done part A. Now part B is hence or otherwise. Now tan theta or tan 4 theta is going to be sine over cos. So we also need to actually equate real parts. So that gives me that cos 4 theta is, now the real parts is cos to the power 4 theta minus 6 cos squared theta sine squared theta plus sine to the power 4 theta. And tan 4 theta is sine 4 theta over cos 4 theta. Let me just make a bit of room. And this is 4 cos cubed theta sine theta minus 4 cos theta sine cubed theta all over cos to the 4 theta minus 6 cos squared theta sine squared theta plus sine to the power 4 theta. Okay, so we've got to go ahead and sort this out. So looking at it here, okay, we've got the 4, which gives me the 4 there. And we've got 2 terms on the top, 2 terms on the top. We've got 3 terms on the bottom. We've got 3 terms on the bottom. So we're almost there. Now, if I divide top and bottom by cos to the power 4, this will become 1. This will become tan to the power 4, which gives me this one. Okay, don't think it quite gives me the top. Let's have a look. So divide top and bottom by cos to the power 4 theta. And that gives me 4 cos cubed theta sine theta over cos to the power 4 theta minus 4 cos theta sine cubed theta for cos to the power 4 theta. And all that is over cos to the power 4 theta over cos to the power 4 theta minus 6 cos squared theta sine squared theta over cos to the power 4 theta plus sine to the power 4 theta over cos to the power 4 theta. Now we can do a little bit of cancelling. So 3 of those will go with 3 of those. 1 of those will go with 1 of those. These will go to just 1. 2 of these will go with 2 of these. And these will go to tan to the 4 theta. Okay, but let's go ahead now and work this out. So we've got 4. Sine theta over cos theta is tan theta minus now 4 tan cubed theta. And on the bottom we've got 1 minus 6 tan squared theta plus tan to the power 4 theta, which is what we had there. So that now is done. And the way I spotted it was looking at the one that was just a number 1, and then that told me what I needed to divide by, and I just went for that. Now let's look at part C, sorry. So this one isn't very easy to spot what to do. So I'll just write these out. So if we look at here, we've got 4 tan and 4 tan cubed. So think of x, let x equals tan theta is what we're basically looking at. So let's take the 2 4 ones over to the other side. So that's 4x minus 4x cubed. Okay, and that leaves me with x to the 4 minus 6x squared plus 1. Which, if I write it round this way, 1 minus 6x squared plus x to the power 4. It's in this form, isn't it? 1, 6 tan squared plus tan to the power 4. Now if I divide by that, so divide both sides by that, I get 1 equals 4x minus 4x cubed over 1 minus 6x plus x to the power 4. So that basically means that this now, when x is tan theta, is this, which equals this. So we've got tan to the 4 theta equals 1. So again, I'm basically going to normally I just let the 4 theta equal x or y or something like that, but let's just do 4 theta is pi by 4, isn't it? And if I think of my cast rule, that's pi by 4, that's pi by 4 for where tan is positive. So 4 theta is going to be pi by 4 plus pi will give me 5 pi by 4. And I'm going from 0 to pi in terms of the actual angle here. So plus another pi will be 9 pi by 4. And then 13 pi by 4. And then 17 pi by 4. But this 17 one isn't going to give me a unique answer, so I can stop there because it's 4 theta, so 4 unique values. Okay, so therefore x equals tan of now, let's get the theta. So theta equals pi by 16, 5 pi by 16, 9 pi by 16, and 13 pi by 16. So therefore x is tan each of these values now. So x is tan theta. So substituting each one in, we get 0.19891 and we get 1.4966 minus 5.027 and minus 0.6682, which then to 2 decimal places is 0.2, 1.50 minus 5.03 and minus 0.67 to 2 decimal places, which was required in the question. And obviously if I carried on going, like the next one was 17 over 4, so it would have been 17 pi over 16, and if you put that in you get back to this answer. Okay, so 4 unique answers, and if I carried on going I just keep on getting these 4 back up. So that was the final question. Definitely I feel getting a little bit harder now in FP2. Okay, so let me know how you're finding it so far. Let me know in the comments. And don't forget to like if you found the video useful, subscribe if you're yet to, and if you're willing and able to help me out financially, please hit that join button. It will allow me to make more of these videos in the future. Anyway, catch you soon.